Okay. Hello, everybody, or I should say hello to everybody who's joined so far. So, good morning, and thank you for joining our Customer Connect webinar for September. I will give exactly 2 minutes, and then I will get into our webinar today. So yeah, I'll give till 11:02 just to let anybody who's straggling come in, and then we'll get started. So. Um, we'll see.
Good afternoon. I just noticed that the Read AI is still there, so if you want to kick it out, do it.
Oh yeah, good idea. Thanks, Bridget. These we've been trying
It's
to
really
figure out
annoying.
yeah, I know. We've been trying to figure out this meeting capturer note taking these days. And the Read AI one seems to be impossible to get rid of once we did our little trial. So
Oh, okay, so I'm not the only one.
Yeah, and it's funny because it seems to spread as well because
It does.
if I bring it into my meeting, then it'll send you an email and then you sign up and then it brings it into your email or your meeting and it keeps going. So,
Exactly.
yeah.
It's very, very irritating.
Yes, I know. So, we're on the Otter one now and that one is actually it's better because I've set it up where it only follows me into hosted meetings and it only sends emails to people with my email domain.
Okay, that's better.
Yes. Yeah, so I'll pitch Otter AI there for anybody.
Thank you.
Hmm. Thanks for joining today, Bridget. Okay. Yeah, well there I'll just get started. I mean, we are recording this event, and so the recording will be available afterwards. But yeah, let's get started into it. So again, thank you for who joined for coming to our September Customer Connect. Our Customer Connect, just for anybody who's new, is just a monthly webinar we're hosting where anybody can join any of our customers. It's really exclusive to our customers. We don't really advertise it to everybody. And so our customers can come. We'll always have a feature focus. And so this month we're going to do a beam steering demonstration and how you can beam steer with Simac. So we'll always have a focus, and then I will open it up to any questions or feedback. And then additionally on the registration, there's a slot for any questions or demos. And so we had a couple this month that I'll also cover. And I guess as we're going through it, so just, if feel free to kind of interrupt me at any time or raise your hand if you have any questions, and I'm happy to just slow down and discuss or answer any questions as we kind of go through this. So yeah, let's start. So today, the reason I'm going over beam steering is just from feedback we've had from a lot of our customers, especially physics programs. We find beam steering is one of the most effective kind of procedures or lessons that are we can teach with using our simulator. So I just wanted to go through kind of what beam steering would look like on Simac, and then so we'll run through that and maybe we'll do some water tank scans and compare our profiles. So we always start by going to Simac, and we're going into Simac 2. And I'm going to run it in the Klystron standing wave or our variant type simulator. And so when we talk about doing beam steering, where we're going to want to investigate is our steering tab. So we ran a 6MV, so we'll just do this with a 6MV beam, and we'll head over to our steering tab. And so in our steering tab is where we have everything to do with the accelerator and really our steering coils. So you can see we get our radial gun error and our transverse gun error. So that's going to be able to allow us to introduce error to our profiles and create asymmetry. And then we have all of our coil currents, of course. So our radial buncher and our transverse buncher, and then our radial and transverse, radial and transverse position coils, and then our angle coils as well. So if we want to run and do some asymmetry, what I'll do here is I'll introduce both a radial and a transverse error. So we'll do like around a 0.5, and I'll do a minus 0.5 in our transverse just so it kind of goes the other way. And so around the the 0 to 1 range is where, we want to introduce our error, and it's going to create us errors that we're going to be able to see physically, but not errors that are too big that, would just kind of be a little bit too much asymmetry to kind of be investigating, or it would just be a little bit out of the norm of the clinic, right? So we introduce an error, and so we get a pretty bad asymmetry here in both our in plane and our cross plane profile. And so obviously that has to do relative to the positive and the negative that I applied to the error. And we can check out at Dmax, kind of our most useful output. But then of course you can check it at any of these depths. You can also normalize them to each other, which again in this case isn't very useful. But another useful one on this to just kind of see small changes in symmetry is our mirror function. And so when you select the mirror function, it'll just flip your profiles for you. And so with our large asymmetry, it's very easy to see kind of naturally on a plot. But when you have very, kind of smaller asymmetries, doing this little mirror function allows you to kind of flip it and see if there's any changes from side to side. Okay, so I'm going to save this state. And so we can call this state, why don't we call it our 6MV, and we could call it our error. So we'll call it our error run. And so I'll save that state, and I'll just kind of confirm in my save states. Okay, so we saved it, so that's good. And so now we can change things, and then we can always come back to that state when we need to. So now what we want to do is we want to correct our asymmetries. So our radial gun error, we're going to want to go to the radial position coil current, and we're going to want to give that some milliampage. And so I'm going to give it -80 to try to steer it back. And then we'll do our transverse position coil current as well to get our cross plane back symmetrical. And so I'll give it the opposite, and I'll give it the 80 milliamps. And so we can run this simulation now, and then we will see the output of our profiles. And then just the reason that I'm kind of saving them, and it becomes good practice to save the beams that you'd like to investigate, is we'll run through the water tank after, and then we can look at them on the same plot. Okay, so then we can kind of see here, and this is what I wanted to demonstrate, that we oversteered it. So, our in plane profile, we had asymmetry to the left, and now we have it to the right, and vice versa in our cross plane here. And so this is good. And so we can call this now our 6MV oversteer. And that's great. And so we can save that. And then we can just, in our load state, we can just confirm that oversteer is still there. And then we can just kind of do some more fine adjustments. And obviously I have the golden numbers in front of me of how to get us back. But this is where then you could, really have to play around and really go back and forth between values to find out which is going to be the current that's going to get you back to your highest form of symmetry. So we'll run this, and then we get out, and we're pretty flat here. I could probably do some, or I could do some more adjustments, some more fine adjustments to really see a symmetry closer to 0. But what I'll show you here is the mirror. If we look at our cross plane profile and we mirror that, you can just kind of, it just allows you, though, with those kind of red line errors, it just shows you a little bit more that it's not truly flat and that there is kind of that asymmetry involved. So that's great. So we'll call this steered, and we can, save it as our steered. So we can save state, just confirm that it's there. Great. So now we have our 3 profiles that we wanted to see through our steering, our kind of our initial asymmetric one, our oversteered one, and then our flat one. And so what we could do is then we can kind of mimic that here. And so we can do our 6MV error, and then we can select our 6MV error. We'll do them all in the cross plane, and we'll do the depth of what's D max again is 1.9. Or I should know what D max is, but we can just do it at 10 centimeters. And then so we'll run this experiment, and then we'll be able to run the other two quickly after, and we'll be able to kind of see. We'll then be able to overlay them, and it's just a nice kind of end result to then see we went through this and we oversteered it and then we corrected it. So, and then we'll call our 6MV oversteer, and we'll grab our oversteered one. We'll do it at the same depth just so that we're looking at data in the same spot. Of course, you could make that depth, you could do multiple depths, or you could do, a different depth, more of your Dmax or values that would be more useful to investigate. Or maybe you could do like your 10 and then your 20, and you could get a 10/20 values. And so we ran our oversteer, and then we'll run our what did we call the last one? Was it just steered? Yeah, and then we'll run our steered. And so again, cross plane, same distance, same depth, I should say. And we'll get this, and then I'll just quickly throw them up on the compare. And then that's essentially what we have for our beam steering. In the future, we would love to be able to kind of introduce a randomized error, so that you don't have to, find good errors and then find the values to correct them all the time, but we aren't quite there yet. Then we can come to our compare, and so here are three. There's our error, our oversteered, and our steered. And so then you can get a couple more values out as well. And then we can even, I mean, they're pretty already normalized, but then you can just kind of see the differences. And then if we wanted to plot more depths, or different energies and compare them as well, then you could come here and compare all that. So just, yeah, in a quick, little 10-minute run through, that's kind of how we do beam steering or teach beam steering. That's directly on the simulator. I will also show, to kind of get the introduction to beam steering or to do it off the simulator in kind of a more simple way. We also have in our Simac labs, which are located in the course space. We do have steering labs for both, the 270 and slalom bending magnet. And I believe, yeah, we actually have two for each. So we have steering 270-degree bending magnet, 270-degree bending magnet part two. Okay, apologize. No, those are just for bending magnets, but we do just have we have the steering labs here. So if we were looking at, like, again, the variant type Linax, our steering lab, it just kind of takes you a little bit more where you're here, and then all it allows you to do is adjust that radial current or that transverse current, and then see how that affects our profiles in real time. So it's a very, more interactive and simpler setup. And then of course we can change the magnet that we're giving coil or current to, and then again investigate those. And as well with this, we do have a save state where, you can save this state. You can put it up on there, change the values, see how that affected your output. And again, if you'd like to save that, we can save that and display them both, and then keep changing more and keep saving more. And then there's a set of 10 questions that'll take you through really understanding this phenomena. So if we looked at any of these questions, there are three sets of coils in this lab. Describe their physical difference. They're just important things that I should honestly be better at and be able to answer for you off the top of my head. And then we get into things of actually like applying real numbers. So for the buncher coil, apply 30 milliamps to both radial and transverse coils individually. What are the symmetry values in each scan direction? So it really just makes sure they go through all the theory and understand the important parts of beam steering or whatever topic we're talking about. So yeah, so it starts there. So we have our labs, and of course we have the mirrored lab on the slalom section, or your Electa style Linac, and of course we use the same coil names. So in our variant, they go with more formal names of transverse position coil and whatnot, where in the Electa they use, C1, C2, and what is it, T1 and T2, and so we have that reflected as well, or R1 and R2. So yeah, that's kind of the other we have. So then we have the steering ones in the labs, and then kind of the final bit. I kind of started at the simulator, and now I've gone all the way back to the labs. But if you really did want the introduction, the suggested way that we would say would be to start with the lab, because it kind of gives you a introduction without having to understand all the nuance of the simulator. And then we'll show you in our student resources. So don't forget, in your username is a drop down, and we have the student resources here, and this will give you access to management guides and things, but we also have these procedures in here. And the reason we keep the procedures in the student resources is because all free accounts have 5 simulation runs a day, and the student resource is available for everybody, so we want these procedures also available to everybody. So that's just why they're found here. And then you can see we have an elective beam steering procedure and a variant beam steering procedure. And so what this looks like is it's an Excel form. And what it does is, so it starts out with some instructions, and it'll say, start with the default mode shown. So in our first step here, we choose the 6MV mode from Simac Klystron standing wave menu, right? So just to kind of show that, we would be in our Klystron standing wave. And we're choosing a 6MV, so I have my 6MV selected. And then, so then we would go, so then it says values in blue are default values. So of course, these are all the values kind of defaulted in our steering tab. Sorry, I have this thing kind of in my way of my tabs. I don't want to miss the view though. Out of the way. Yeah, so where were we? So then, yeah, that would be, so then it tells you which screen to go to here. So you can see these are all in the steering screen that we're investigating. And then it asks you to, at each step, change values in the green cells on the Simac simulator. So that's when it wants you to add a 0.5 to the radial gun error, basically what we just did. And then we're going to look at the in-plane symmetry at D max is going to be 3.14. And so this one doesn't have any questions associated with it, but then we go to our step 2 and we change our radial buncher coil current, and we get an in-plane symmetry of 4.18. And so now we have a question, why is the symmetry worse? So it really will, take you through beam steering, first of all. Second of all, it'll help you understand where to find things on the simulator and how, really just how to use the simulator and become familiar with it. And then third, it'll kind of take you through these questions and actually make you understand the phenomenon behind, the changes that we're making to our simulator and to our beamline. So yeah, and that's pretty much what we have going on for steering. Again, we have the elective beam steering as well for its procedure 11. So if you're working with variant versus electa, we always have both of those available. But in a general sense, that is what we kind of have available for beam steering. And like I've said, we just had a lot of great feedback that this is a useful tool, and makes it very easy to teach this topic. So we wanted to make sure that people with access to that were familiar with how to do that. So just trying to think if I forgot anything around the beam steering stuff. We also kind of went over how to look at that in your water tank. So yeah, that's great. I'll just show you on the magnetron side, that there. So then you can see we do have the radial gun error and the transverse gun error, but then the currents on the coils are the 1R, the 1T, and the 2R and the 2T. So more accurate to what you would see in an elected environment. Okay, so that's great. That is our beam steering. So if there's no questions around that, we have something in the chat, but I'm gonna guess it's my note taker. Yep. So that's great. No questions on beam steering. So I will just kind of get into a couple other things of questions that we had on the registration form. So we did have a question around if we can do any vacuum training on Simac or in our work or in our platform, I should say. And so we don't really have anything to do with vacuum. But what we did is we did find a resource on vacuum by the Varian Vacuum Company. And so it's a textbook explaining the vacuum systems. And so we're going to make that available to our users. We're not 100% sure how. I think maybe in our resource or our student resources, we're going to add a new tab that's going to be continued reading or external resources, and we're going to put some open source resources that we've used, and they're available to us, just for some stuff that we don't really cover on the platform, like vacuum systems and maybe imaging. I would love to put up some of our papers around how Simac is made and how it actually operates. And so in the next coming weeks, we'll hopefully get that there for you guys, and we'll send out, an update about that new feature and how you guys can access it and whatnot. So, um, and then the only other question that we had, let me just pull it up, was just around, oh yeah, it was just around getting data out. And so that's definitely possible as well. So I'm just going to share again. So the question was, is there any ability to get the data from the water tank data to be able to run my own, calculations or experiments? And the answer is absolutely yes. And the only way you need to do that is in any of the steering and treatment head screens. Um, or actually any of the screens. So in the modulator and the gun, so you'll notice we have a couple different versions of graphs. So unfortunately in our guns, you aren't able to grab the data. In our modulators, in this format of graph, you can, and you can see here, you can download the plot as PNG, zoom out, zoom in, show closest data, hover, compare data, produce with Plotly, produced. Um, I thought we could export these ones. Sorry, guys, I should have been on this. Okay, but I will say though that I'll work on making these ones on figuring out how to get the CSV out of these ones because we should have them in all of them. So this is a great question. Thank you. But on our water tank profiles, which are kind of the most important, which I would assume we'd want to export to kind of do our own calculations. So in our treatment head, in our steering, and in our photon beam, we have an export to CSV button right here under the graph on the mall, and then it just asks you to save it in a place. Um, and I'll just say symmetry. And then I'll just show you what that looks like and what data gets saved for you and how we look at that. And again, yeah, and so you kind of have to download it separately for the in-plane versus cross-plane. And then again, for the flatness, it's a little bit different. And then on the photon beam, again, you have to do it separately for the PDD. But quickly, you can just see this is what the results output. So it gives you the dose per pulse at 10 centimeters for each distance away. And so you'd be able to then take that data, plot it, run it through any types of manipulators you'd like, and just kind of do whatever you'd like with that. So that's a great question, and we do have that ability on our water tank ones. I do think the plans for the next version is to update all our graphs to these same Plotly outputs. I know we have some issues just with trying to make it faster and not have it slow down with graphing these plots, but that's something I will pass along to the development team to make sure that all graphs have that output or that export feature so that we can investigate. So you can investigate on your own. You can kind of take the data out of Simac and investigate. So yes, thank you for that question. And I think that's all the questions that we had on the registration form this month. So I'll open it up. I know we don't have many people here today, so I'll open it up if there are any questions or any feedback that you'd like to discuss right now. And if not, I would just, say appreciate you guys coming and joining me today. And I hope it was useful. And then please feel free to leave suggestions for the next webinar. We hope to see you at the next webinar. And then I will follow up. You'll get an email that the recording is available. And maybe just, again, just to kind of show the recordings are always available in the student resource portal. So again, we go to the student resources, and then it's just down at the bottom here under webinar recordings. And so the registration link's always there. I believe this one will be for the old one for this session still. But then if you missed our first session or our beam saving session, you can catch them here. And then I'll update this for the next one. Okay, perfect. So yeah, if there's no questions, we can leave it there. And that's kind of the new format. I'm just kind of making them half an hour for now, just so that it's a little bit easier for people to attend and we don't, drag on talking about nothing. But I'm happy to stay longer in the future, if we have more participants and we get into discussion or anything like that.
Thank you very much. It was very useful.
Okay, amazing. Thanks, Bridget. Thank you for joining.
So
yeah, thanks, Gwen.
Yeah, thanks, Bern. And I will tell you, Bern, because I know you're waiting for it. We're getting closer with our V3, and as soon as we have something for you, we will get it to you. And so I'm hoping in the next couple months we will have something for you. I know I kind of said something by the end of summer, so I just wanted to update you that it's coming.
Okay, yeah, looking forward to that. Thank you.
Great. Yeah, and then as soon as that one's launched, I'm sure our Customer Connect webinar will be a good one that month. We'll go through all the new features.
Great. Okay.
Okay, guys. Perfect. All right. Thank you.
Bye.
Yeah, have
All
a
right,
great day.
thanks.
Yep, and we will
you
chat
too.
later.
Bye.
Oh.